Okay, so I'm just going to do a quick recap of some of the lessons that we did before, back when we were still in the classroom, just to kind of help you guys out with the test since we can't, or since I'm not there to answer questions. But still feel free to contact me if you guys have any questions on the review or anything. Okay, so a circle is the set of all points that are equidistant from a given radius. So that's the definition of a circle. And then just some terminology reminders. When we talk about something being on the circle, that circle itself is the actual drawn part. It's not the inside, on, and outside. So if you say something is on the outside of the circle, you're not saying on this part right here, you're saying out here. Likewise, we don't say on the edge of the circle if it's either on the circle or it's not on the circle. Okay, so there's no such thing as on the edge of the circle because what you're thinking about as the edge is the circle. Okay, so a radius goes from the center, it's a segment from the center to a point on the circle. A chord is just it's a segment where both endpoints are on the circle. And then a diameter is a chord, so two endpoints on the circle, but it's a special chord that has to go through the center. And as you're naming these, just the biggest thing with these, obviously make sure you know what they are, but also pay attention to the notation, the symbols that you use to represent, because some of these things, it makes a difference whether it's a segment versus a line. Big one being a chord versus a secant. A chord is a segment, a secant is not. So if you're writing the name of a chord, make sure you use just a single line. Remember, that's a segment. So if it's like segment AB. Okay. Then some of the other ones we discussed. Sorry, just trying to get this to let me click. All right, there we go. Sorry about that. All right, so then secant then is a line that intersects the circle at exactly 2 points. So for a secant, make sure you use a line with arrows on it. Okay, tangent, so secant intersects at 2 points, a tangent intersects at 1 point, and then that point that it intersects is the point of tangency. And then common tangents are lines that are tangent to more than one circle. Alright, so just going through these things real quick. AC, notice that it's segment AC right there, that is a radius. AB goes from one end to the other, and it goes through the center, so that is a diameter. And then ray DE, so that's over here, that goes, it touches the circle at just 1 point, so that is a tangent. AG, notice this one is line AG, so that goes through the circle at 2 points. And then we're looking at segment AG, which is a chord. So I just want to remind you guys about the difference between those two things. The main difference between a chord and a segment, or a chord and a secant, is a chord has to be a segment, a secant has to be a line, so make sure you use the correct notation on that. All right. So circle A is this one right here. The radius would be from this point to a point on the circle, which in this case is 3. The diameter would then be 6. If you look over here at circle B, this one has a radius of, you can count 2 boxes, so it's a radius of 2, a diameter of 4. How many common tangents? So again, common tangents are tangent to, it's a line that's tangent to both of the circles, and each circle has infinitely many tangents, but as far as common tangents to where you could draw it being tangent to both of them, we looked at these. If they're completely separate, like this first group, there's going to be 4 possible ones that you can draw. So the top, the bottom, and then crisscross in between. If they are touching, so it's the circles in and of itself are, you could consider tangent to each other, then you're going to have one on top and bottom, just like with the previous one, but then you're just going to have one straight down through the middle. So that one has 3. And then this last one, if they overlap, you can still have the top and the bottom one, but you can't have a tangent going between them, because the only way to be tangent to one circle between them would be going through the other, since those overlap. Alright, so then here's just a couple rules that we talked about with tangents. One of them said that radius from the center to a point of tangency is always perpendicular to the tangent line. And then the other one said that if you have 2 tangent segments, their distances are equal. So that's here and here. So from this point, from the point of tangency to the point where those 2 tangents meet, that length has to be the same. Okay, so just looking at a couple of examples using those. Here we asked, is the radius, or PT is the radius, is that tangent? So we were looking at it and we said, it looks tangent. We talked in the class about how it looks tangent, but we can't just look at it because we don't know for sure if it goes just a little bit inside or all the way. So what we need to do, based off of those rules that we just talked about, those theorems that we just talked about, we need to determine if this is a right angle. So to do that, we use Pythagorean, or we use the converse of the Pythagorean theorem. So we want to see if 12 squared plus 35 squared equals 37 squared. And it does. So that means that this has to be a right triangle. And for this to be a right triangle, the right angle has to be across from the biggest side, which is SP. So that angle up there has to be our right angle. And so that has to be tangent. Alright, now this time we're told it's a point of tangency, so we're told that it's tangent, meaning we know that there's the right angle here, but we have to find the length. So now instead of using the converse of the Pythagorean theorem to try and decide if it's a right angle, we know it's a right angle, so we know it's a right triangle, so we can just use the Pythagorean theorem. Remember that the hypotenuse, or your C, is the one across from that, and in this case that's 50 plus r. So we have 80 squared plus r squared equals 50 plus r squared. And then the important thing to remember when you take r plus 50 or 50 plus r, if you wrote it either way, you're going to get the same result, is remember you can't just square the r, square the 50. You have to, squaring means multiply it by itself. So you have to take r plus 50 times r plus 50, and you have to FOIL. So r times r times 50, 50 times r, and then 50 times 50, which will give you that. Combine your like terms. You can subtract r squared from both sides. You can subtract 2,500 from both sides. And you end up with the r equaling 39. Alright, and then this one is looking at these two tangent lines. They're both tangent. We're told that RS is tangent at S, RT is tangent at T. They both meet out here at R, so those two lengths have to be the same, meaning 28 and 3x plus 4 have to be the same. And subtract 4 from both sides, divide by 3, and you get 8. And then if you went ahead and plug that in, 3 times 8 is 24, plus 8 is 28, so you get 28 and 28 for both of them, so it works. Alright, so I'm going to go ahead and stop here because the rest is just extra practice of that. And right now we're just doing a quick refresher, so I don't, if you want to go back through and practice those problems again, you're welcome to. But for the sake of this video, I just wanted to do a quick refresher on some of those things that we talked about in class.